6 million years ago, the world was not our own. The seeds of our story were being sown upon its ancient soil. Well, the sun rises, a familiar golden orb casting long, stark shadows across an alien yet recognizable landscape. Long before recorded history, before cities, before the written word, we glimpse this period through science, piecing a narrative from fossilized bone and stone, continents still settling into modern positions, younger, jagged mountain ranges, climate in slow-motion flux, the stage for our earliest ancestors, the hominins, cool pre-dawn air, damp earth, blooming vegetation, unseen animals' musk. No highways, no urban glow, just a pristine horizon. The world of 6 million years ago was a dynamic and varied tapestry of ecosystems, a concept scientists refer to as a mosaic environment. In the heart of Africa, where many of our earliest ancestors' remains have been discovered, this was especially true. Imagine vast expanses that were not simply dense, unbroken jungle or wide, featureless plains, but a complex mix of both. Patches of thick, humid forest, towering trees, and shaded undergrowth interspersed with more open woodlands, where the canopy thinned and sunlight dappled the ground. Wooded areas would bleed into sprawling grasslands or savannas, dotted with acacia trees and hardy shrubs, creating a rich, diverse habitat that supported an incredible array of life. This environmental variety resulted from long-term climate change. The Earth entered a cooler, drier phase, causing immense tropical rainforests to shrink. As rainfall became less reliable and more seasonal, grasses and plants adapted to drier conditions thrived, pushing back the forest edges. One of the most defining characteristics of the human lineage is the way we move. The shift to walking upright on two legs, known as bipedalism, was not an overnight event, but a slow, evolutionary process that began with these very hominins. Sahelanthropus tchadensis. Fossil skull suggests a more forward-placed spinal column. Ardipithecus ramidus, a mosaic of climbing and walking adaptations. They were not yet the masterful, striding bipeds we are today. Their gait might have been somewhat waddling and inefficient. The driving force behind this monumental shift was likely the changing environment. Forests thinned and savannas expanded. Distances between reliable food sources, like isolated fruit-bearing trees, grew larger. Traveling across open, sun-drenched spaces on all fours would have been slow and energetically costly. Standing and walking upright, even for short distances, offered key advantages. It raised the head. Better vantage to spot predators lurking in tall grass. It also let them see distant resources. Upright posture exposed less of the body to direct overhead sun, helping regulate body temperature on long foraging trips. Perhaps the most revolutionary consequence of bipedalism was what it did for the hands. Freed forelimbs opened a world of new possibilities.
Hands were available to carry objects over long distances, share with its young, share with other members of the group. Hands could also hold infants. Mothers moved with dependent offspring more securely. The liberation of the hands from walking was a pivotal moment, but it was the evolving structure of the hand itself that unlocked the next chapter of our story. The hands of early hominins were developing a more robust and opposable thumb, a feature that dramatically enhanced their ability to manipulate objects with precision. While their ape cousins had powerful hands for climbing and for knuckle walking, the hominin hand became a tool for fine motor control. It could do tasks requiring a delicate touch and a stronger, more controlled squeeze. Initially, tool use was opportunistic and straightforward. A hominin might have picked up an unmodified stone to crack open a hard-shelled nut, gaining access to the rich, fatty kernel inside. They might have used a fallen branch to dig for edible roots, or to poke into a termite mound. These were not manufactured tools as we think of today. They were found objects used in the moment to solve a problem. A hominin might have discovered a stone with a naturally sharp edge was more effective for scraping meat from a bone, or for cutting through the tough hide of a scavenged carcass. This would have been a game-changing realization. That quiet act of picking up a stone was, in reality, a thunderous step toward human ingenuity. The daily life of an early hominin was overwhelmingly dominated by the relentless search for food. Their diet was not that of a specialist, but of a generalist omnivore, a strategy that provided resilience in their changing and often unpredictable world. They were expert foragers, possessing an intimate knowledge of their local environment, passed down through generations. The bulk of their caloric intake would have come from plant matter, fruits from trees and shrubs, tender young leaves, and pith. Their diet was a seasonal affair, shifting with the availability of different resources throughout the year. When fruits were scarce, they turned to what lay beneath the ground. Using simple digging sticks or their bare hands, they unearthed nutritious tubers and roots, starchy storage organs providing reliable carbohydrates. This was especially important in drier, open savannas, where fruit trees were less common. They also supplemented their diet with small, easily acquired protein sources: insects, protein-rich termites, and grubs. Bird eggs, lizards, and other small animals were taken when possible. The role of meat was small but significant. 6 million years ago, hominins were not apex predators. They were relatively small, lacking formidable claws or teeth, no match for large carnivores. So they didn't hunt large game. They were opportunistic scavengers, moving in cautiously on predator kills. Using sharp-edged stones, they sliced meat and smashed long bones to reach calorie-dense marrow, a food source unavailable to most other animals. This dietary flexibility was a cornerstone of their success. The search for diverse foods drove exploration, sharpened cognitive mapping skills, and encouraged innovation. For a small, relatively defenseless hominin navigating a world filled with powerful predators, there was no greater asset than the group. These early ancestors did not live solitary lives. They were intensely social creatures, living in small, cooperative bands of related individuals. This social structure was a fundamental survival strategy. Safety in numbers, multiple pairs of eyes and ears. A united group could present an intimidating front, sometimes driving away a lone carnivore. Bonds between mothers and offspring were paramount. Infants were born helpless and needed long dependency. They had to be carried, protected, and fed for years. Extended childhood gave time to learn how to find food, how to avoid danger, how to navigate social dynamics. Care likely came from mothers and from older siblings or related females. Cooperative breeding. Communication was complex but pre-language. Gestures, body postures, facial expressions, vocalizations, grunts, hoots, calls. Grooming was vital. It kept hygiene, built trust, resolved conflicts, and strengthened alliances. These interactions were the glue of society. Survival was a team effort, their social bonds the most powerful tool. The world of 6 million years ago may seem unimaginably remote, a lost chapter in the deep history of our planet. Yet the quiet drama that unfolded each day in that ancient African landscape is the foundational text of our own story. The small, incremental changes that began during this era. The tentative first steps toward walking upright. The simple act of using a stone to break a nut. The formation of cooperative social bonds set in motion an evolutionary cascade that ultimately led to the emergence of Homo sapiens. We are the direct inheritors of those adaptations. Walking reshaped our anatomy, but its true significance was in freeing our hands, agents of our ingenuity, guided by a growing brain. From picking up a naturally sharp rock to designing a smartphone is an unbroken continuum of innovation. The mind that saw a tool in a stone is the mind that composes symphonies and sends probes to the edge of our solar system. Those first faltering steps on an ancient African savanna were the very steps that made our modern world possible.